Hello, everyone, and welcome to Talk Nerdy. Today is Monday, January 4th, 2021. Yes! And I'm the host of the show, Cara Santa Maria. We've got a really exciting episode for you today, but before we dive into that, I do want to thank those of you who continue to make Talk Nerdy possible week after week after week after week after week. Remember, Talk Nerdy is and will always be, this is my pledge, 100% free to download. So we depend on support from listeners just like you. There are a lot of ways to support the show by rating and reviewing on Apple Podcasts, Google Podcasts, wherever you download your podcast, by taking a peep in the Talk Nerdy merch store. You can go to talknerdymerch.com or talknerdy.com or carasantamaria.com. All roads lead to merchandise. And the best way that you can support the show is by pledging your support via Patreon. So I want to thank this week's top patrons, and they include, we've got a new patron that I want to thank from the bottom of my heart, Leonard Prince, and also Michael Gaucher, Mary Neva, Christopher Pitts, June Sapara, Pasquale Gelati, Ulrika Hagman, Dudas Infinitas, Charles Payet, Brian Holden, Pedro M. Rosario Barbosa, Daniel Lang, David J. E. Smith, Robert Christ, and Elise Christie. Thank you all so very much. It's because of you that we get to keep on going. And keep on going we shall. This week, it is, I think, the best way to start the new year. We actually recorded this week's episode on the last day of 2020. So what better day than to end the flaming dumpster fire of all years than to discuss with Dr. Katie Mack her new book, The End of Everything, Astrophysically Speaking, of course. Dr. Katie Mack, you may know her. If you don't already follow her on social media, you must, because you will get so much amazing content and a lot of giggles if you do. But she is an assistant professor of physics at North Carolina State and a member of the Leadership in Public Science cluster, which allows her to do a lot of incredible public communication of science. Her book, The End of Everything, Astrophysically Speaking, was supported by the Alfred P. Sloan Foundation for the Public Understanding of Science. Katie is a dear friend. She was actually my 5th ever guest on Talk Nerdy, and I mentioned this at the end of the show, so any of you who'd like to go back and learn all about dark matter, we had a fun chat in 2014. Oh my gosh, it had been way too long. So I was super thrilled to have her back on the show to talk about how the universe might end. A little light conversation that actually does end up being really funny, really profound, really meaningful, just like her book. So without any further ado, everyone, here she is, Dr. Katie Mack. Katie, thank you so much for spending this time with me here on the last day of the dumpster fire that is 2020.
I'm very happy to be spending this time with you, Cara.
So yeah, we were talking about, of course, your new book, The End of Everything, Astrophysically Speaking, and how you really do dive deep into these scenarios of the different ways that the universe could end. And of course, in doing so, teach us a lot about what we know about the universe as it stands. But how fitting, like when we were texting about this, you're like, yeah, we'll talk about the end of the universe on the last day of this year.
Yep.
Oh my God.
Yeah.
I think most people probably aren't looking forward to the end of the universe, but I think many of us have been waiting with bated breath for the end of 2020.
Well, I mean, we can only hope that something better comes along. We may or may not get that lucky with the universe, but at least with this year, we can hope that when this year ends, we will have another, and it's very hard to see how it could be as bad.
Seriously. I mean, unfortunately, probably when the clock strikes midnight, which as we're recording this has already happened in like half the world, I don't think any substantial changes are going to take place. But there is that hope. There's that kind of resetting that we often do. And of course, I think there are some really significant improvements that we have to look forward to.
Absolutely.
But when it comes to the end of the universe, we may not be so lucky. So I've got to ask, before we even get into, the sort of technical things, the big picture things, all of the interesting cosmology that you share with us in your book, what compelled you to focus specifically for your first, popular science book. I say first because I know more will come. I have faith in you. What, what compelled you to dive into this very big topic, which in many ways is actually not, terribly related to the research that you do currently?
Yeah, well, part of it was that I, I give a lot of public talks about my research about dark matter and about cosmology in general. I give talks about sort of where we fit into the universe and what we're learning about it and, all of these big topics, right? And I've noticed over the years that one of the topics that people get most excited about when I talk about it is the end of the universe. And it's related to some of the research I do in certain ways. And it's this thing that's kind of thrilling and weird and scary. And I realized when I was thinking about writing a book that there just aren't that many books about the end. There are a lot of books about the beginning and a lot of books about sort of cosmology in general or about, specific topics like gravitational waves or black holes or whatever, but not very many books about like how it's all going to come to an end. What is the ultimate, finale of our cosmic story? And I realized that there are a lot of really interesting possibilities, and they all tie into areas of research that I've worked on or that I'm particularly interested in, things I've been following over the years. And they all sort of connect to really important, interesting physics and cosmology topics that would be really fun to write about. So it kind of all came together as this is a way I can put in all of my favorite stuff about cosmology, all of my favorite things about the universe, and also show people kind of the cutting edge of where we are with cosmology, what we're learning right now. And it's a topic that I knew people would find kind of thrilling. And so it was this sort of perfect storm of this is the place where, because I have my own sort of special interest in this idea, and because I've worked in so many different areas of cosmology that kind of span the range of these different possibilities, it was really just the perfect topic and the perfect time, especially because, I started writing this around like 2017, and everybody was feeling a little bit, a little bit sort of the world is ending. So it also kind of fit a mood, I felt like.
Which only accelerated in the coming years.
Exactly,
for sure.
yeah.
And so were you done with it before the global pandemic really struck? Were you completely finished with the production of the book?
Yeah. I mean, I was doing the final edits in sort of February of this year, and so it was supposed to come out in June actually originally because I had all my final edits in, and then it was going to come out in June. I was going to do this huge book tour, go all over the world, and then it got pushed back to August because of the pandemic, but all of my stuff was done before any of the kind of lockdown and things started. So it's been a bit weird to, have this huge build up, spend a couple of years writing the book, thinking about all these events I'm going to do and scheduling it all out. And then as soon as I'm done with my bit and everything's scheduled, it's like, oh yeah, none of that's going to happen.
Right. And the world falls into chaos.
Yeah.
Okay.
So it's been a very weird time to release a book. I did my whole book tour in quotes from this desk in front of a microphone in front of my computer. So it's been very strange, but it's this kind of book that I think resonated with people, and a lot of people told me that it was, it sort of had a strange hopefulness about it, or at least catharsis. And so I think it's been a good publishing experience despite the sort of chaos of everything.
Well, and the funny thing is, like, not to wax poetic so early in the conversation, because I think that there's some big philosophical, kind of eschatological, obviously that's the core of the book, issues that will be really fun for us to talk about. But I've been reading lately a lot of like more fundamental existential philosophy as it relates to my work in psychology.
Yeah.
And when I was reading Heidegger recently, one of the things that I was really reflecting on was this idea that he often puts forth that we all know we're going to die, and to
Mhm.
express that or to experience the concept that we are all going to die is one thing, but then to really reflect on the fact that I personally am going
Mhm.
to die is a
Yeah.
completely different, existential dread.
Yeah.
And there's something about the collective
Mm.
universal death that is weirdly, like you said, it's not just a bit, it's like freeing in a
Mhm.
way.
Yeah.
It's
Yeah.
and there's almost like an absurd humor to it. And of course, the way you
Exactly.
write has a lot of humor in it as well, which I
Mhm.
think is such a good balance to a topic that could be really dark and heavy, but comes across kind of like absurd and fun and fascinating and a little sad, but mostly
Yeah.
just like, WTF.
Yeah, yeah, it's funny when I get interviewed about this book, one of the comments that I get most often is the interviewer will say, "It's a little disturbing how much you're smiling right now." And, because I do find this stuff weirdly sort of joyful or thrilling or something where it's really fun to talk about this ultimate destruction, despite the fact that this is obviously bad, right? We don't want the universe to end, but there's something yeah, it's thrilling. It's like that moment on the top of a roller coaster, or when you're really scared by a horror movie or something like that. It's separate from you. It's not a direct threat. You
Right.
don't have to be personally scared for your own safety, but it's big, huge destruction. It's mind-boggling. You can't really conceive of it. It's you know just this total chaos, and that somehow tweaks something, and there is a little bit of sort of laughter in that's hard to
Right.
explain.
I love it. I mean, and it's something I see a lot when I study existential philosophers, that there's always this, it's such kind of a deep and, fundamentally sort of, like you said, like gripping or ontological
Mhm,
um experience, yet many of them revel in the absurdity, and
mhm.
humor is actually like a function of their writing,
Yeah,
which resonates a lot with me personally.
yeah.
You're right. There's a distance in a weird way
Mhm. Yeah.
between I'm not personally at risk, but my entire, not just my species, but my planet and my home and,
Mhm.
my progeny and everything, culture, society, literally everything that
Yeah.
is will cease to exist, which is, as you mentioned, a little bit unfathomable. Yet you do the fathoming and you bring us into that. And that
Mhm,
parallels with one of the experiences that I have often in working with patients who have terminal illnesses,
mhm.
that there's this weird irony in that we're so afraid of death and we have so many blocks and so many defenses against thinking about our own death. But the minute that we start to learn about it, almost like intellectually and emotionally, some of the fear actually subsides. Like we
Mm,
shine the light on it. And of course, that light shines on those dark corners and we
mhm.
become less afraid in a way.
Hmm. Interesting.
Yeah. And I think that that experience, even if we can't quite put our finger on it, is
Mhm.
something that, your book has as a fundamental layer to it. Like, let's
Yeah.
learn about the ways that the universe could end so
Mhm.
that it's not just this esoteric, you know, eschatological fear, but it's a thing that we can measure in some
Right.
ways and that we can model and maybe not perfectly predict, but at least have ideas of what could happen.
Right, right, and it fits into a story of, a narrative of how the universe works, and it's
Right.
it's it's not this kinda external threat. It's just this is the life cycle of a cosmos, This is the universe had a beginning. It is changing, we see it changing, we see how the universe is evolving over time, and that leads to an ending, and, a lot of people have asked me, like, "How do we know the universe is gonna end?" It's like, well, it had a beginning, it's changing over time, it's not gonna stay the way it is now, we can see that very clearly, and the way it's changing, we also see that it is getting less hospitable to life, less hospitable
Mm.
to structure, to order, and that's something that we can very clearly expect to continue over time. And so it's very hard to envision anything where the universe just stops and holds still, forever. It
Right.
really can't do that the way that physics works. It does evolve toward this ending. And which way it goes, what the ending actually looks like, is still something that depends on things that we're still working out. But we have we can extrapolate what we know now into the future. We can figure out a number of possibilities, and we're learning about the structure and behavior of physics in the universe, and that's giving us these different paths, and we can figure out, over time with more data, which path we're likely to be on.
Right. I've got to ask before we dive into what those different potentialities could be,
Mhm.
how much, because you're a cosmologist who's like steeped in the theoretical physics, right?
Yeah,
Like you study this stuff, you think about it, you do
yeah.
the math, you also conceptualize it philosophically.
Mhm.
Um, Most of us think about these things in more, I guess we could say, metaphorical ways because we may
Mhm.
not speak the
Sure.
functional kind of language of physics or the language of math. And I
Yeah.
think one of the problems or one of the shortcomings of our evolutionary development and the way that we think is that we anthropomorphize things. So when
Mhm.
we think about the quote unquote death of the universe, we often think
Mhm.
about the way that bodies, living beings die,
Right.
and we use that metaphor in our own minds, but that probably gets in our way when we start to conceptualize not so much the death of the universe but the end of the universe,
Mhm.
right?
Yeah. Yeah, although, there are some kind of similarities in the evolution of a life and the evolution of the cosmos. I mean,
Mm,
the universe is getting older. It's slowing down in some ways. I mean, the expansion is speeding up. We can talk about that later, but the production of new things is slowing down, and things are decaying, and that's just a
right.
process that happens in every part of existence. That things decay and things move toward a state of higher disorder, higher entropy over time, and that's just how everything goes, and that happens on the largest scales in the cosmos as well.
Yeah, there actually is that parallel there that over time we have all these things that happen within our bodies that
Mhm.
contribute to the aging process. And of course, after we die, that's like a perfect example
Yeah.
of that entropy process where we just sort
Mhm.
of decay back into the ingredients that we,
Yeah.
came from. Um, and really that's what's happening on a grander scale. So I want to first point out one of the things that thrills me when I'm
Mhm.
reading your words. And one of the things that really resonates with me is that what we know today, based
Mhm.
on the technology that the brilliant minds working within the sciences over, hundreds of years have developed, even thousands of years really have developed, um, is really not a sampling of the universe as it is right now, but
Mhm.
it's an understanding of our past. Because when we
Yeah.
observe, we're
Yeah.
never observing real time, right?
Yeah.
It's such a
Yeah.
crazy concept that I think like
Yeah.
bears a lot of repeating. So help us understand this.
So this is one of my favorite things about the universe, is that because of the way that we gather information about the world, we never see what's happening right now. Everything we observe is a little bit in the past, or a
Mhm.
lot in the past, depending on how we're looking at it. Because when you see something, what you're doing is you're gathering light from that object. If you're looking at the wall across the room, you see it because there's light reflecting off that wall and coming to your eye. And so there's a bit of a delay because it takes light some time to get from that wall to you. So if something changed, there would be a slight delay when it would get to you, and it would only be a few nanoseconds, if
Mhm.
for something across the room, because it turns out that the speed of light is such that it takes about a nanosecond to travel about a foot, if you want to use those units. Um,
Okay.
but when we look at more distant things, we're looking even farther into the past. So if we're looking at the moon, we're looking at something like 1.3 seconds ago. Um, if we're looking at the sun, and of course you want to use proper protection, eye protection, we do that.
Yes.
You're looking at about 8 minutes ago. And if we look at other stars in our own galaxy, we're looking at, years or hundreds or even thousands of years ago. And when we look at other galaxies, we might be looking at millions or billions of years ago. And, it's just a function of distance, right? The farther away the thing is, the longer it takes light to get to you. And that's where we get the unit light year. A light year is the distance light travels in 1 year. So something that's 1 light year away, it took a year for the light to get to you. So you're looking at a year ago if you look at a light year away, right? And so as we look at more distance things, we can see things that are billions of light years away, which means we're looking at billions of years ago. And we can use that to see the evolution of the universe very directly, because we can look at the past. We can look at the past of the cosmos by looking at things that are just far enough away that the light we're getting is so old that light is coming to us from an earlier era. And the universe, we know the universe is about 13.8 billion years old. We can actually see so far away that we're looking at the first few, hundreds of thousands of years. Like we can see light that's taken so long to get to us. It has taken almost the age of the entire universe to get to us. And so we can see light that is from the time when the universe was still in its primordial fire stage at the Big Bang. The Big Bang was a process where the universe went from being this sort of hot plasma-filled fireball kind of state to something that cooled down and became sort of cool gas that then formed into stars and galaxies and so on. But we can see that fireball state. We can actually see the light from that fire directly because we can see so far away that light has taken almost 13.8 billion years to get to us. And the light that we're seeing is the light from that primordial fire. So we can actually see the Big Bang, the final stages of the Big Bang. I mean, I think that's just the most amazing and mind-blowing thing that I've ever learned about the cosmos.
Oh, yeah. I mean, it's literally scrambling my brain right now thinking
Yeah.
about it. Like two things come up for me. One is this sort of, again, with the analogies, but this idea that if you've ever tried to learn a language later in life, you find that there's this constant translation that occurs in your
Mm.
head, as opposed to somebody who's more of a native speaker or somebody who has been really steeped in the language. There's sort of just a natural ability to flip into the thinking of that language. And I'm wondering,
Mhm.
as a cosmologist, do you have the experience like you have to constantly remind yourself that you're looking into the past, or is it just baked in now to the way you think?
It's sort of baked in,
Mhm.
but you don't always really think about it. I like so when we talk about distant regions of the universe or distant objects that we're observing, we generally label those in terms of something we call redshift. Now redshift is the process by which something that's very far, that's moving away from you or that's being moved away from you by the expansion of the universe, its light looks redder to you than it would otherwise. It's basically
Mhm.
because the light is being stretched out by the expansion of the cosmos. And so light that would be, maybe yellow or something when it's emitted, by the time it gets to you, it's redder because the light has been stretched out by the expansion of the universe. So you can use the fact that the farther away things are, the more they're being expanded away from you, but to mark different distances by the redshifting, the how much that light is stretched out. And so we mark distance on these cosmological scales by this redshift, by how much the light has changed by the time it got to us, before it got to us. And so we can talk about something at, redshift 2 or redshift 6 or redshift 10 or whatever. And you end up starting to think of those as just different regions of the universe.
Okay.
So we might talk about a redshift 10 galaxy, and I just imagine that as like, oh, that's a really distant galaxy. But then there's part of my mind that's like, oh, actually, no, that's a galaxy that existed in the first, 500 million years of the universe. It was more
Right.
than 13 billion years ago, and that conversion, you don't always do it, you don't always think about it quite that way, but when you do, it's like it's still mind-blowing. It's still mind-blowing to think that, that's a galaxy that existed when the universe was very, very young. and the processes around it were different. The amount of time it took to build that galaxy was very short because there just wasn't that much time in the universe yet. That kind of
Crazy.
thing is, that kind of thing is just really wild.
Yeah, it is. And it also raises a lot of complicated questions about sort of the architecture, I guess you could
Mm,
say, of the universe, the dimensionality of the universe that, when you think about the fact that very distant things are in essence very old
mhm.
because of the way that we as the observers who are not at the center, although it
No.
feels like we're at the
Yeah.
center because of how we observe, but
Yeah.
aren't at the center. So is there like a conical kind of experience? Like, is there a bending of actual space-time that occurs, not just like the gravitational bending that we often talk about,
Mhm.
but a bending simply because as things are moving away, I shouldn't word it that way. As things are older in time, they
Mhm.
are also farther and continue to move away from us. Does that actually change the shape of the architecture of the universe itself?
Well, the shape of the universe is a complicated idea, but the way that I often envision it is, so imagine a three-dimensional a three-dimensional sort of glass block, or something like
Mhm.
that with galaxies embedded in it, okay? And we're sitting at the top of that, the top layer of that three-dimensional glass block, and imagine a cone, sort of etched into it inside that glass block, where that cone touches different galaxies at different distances. So imagine the up and down direction is time, and the left and right, that's space. And so, the stuff things that are close to us, close to the top of that block, those things are things that are nearby, and we see them in a very, recent time. And things that are
Mhm.
far at the bottom of that block, they're distant in time. We also see them only the distant in space ones, right? So the cone is
Yeah.
widened out there. So we're seeing a slice of the universe, really, this sort of conical. I mean, it's complicated because you have to imagine another dimension up, right?
Yeah.
Um, but but I envision it this way because it's easier to work in this number of dimensions. But it's sort of like a conical slice through the universe, through space and time, where we can only see distant things as they were a long time ago, and we can only see nearby things as they are recently. And we can only see right here, right now.
Yeah.
But those distant things that we see in our telescopes, by now, in some global sense of now, they've changed, they've evolved.
Mm.
They're living in a modern universe now, but they probably look very different. But we just see them as they were a long time ago, and so we're just seeing this sort of slice through the universe. And the reason that we're able to use that to learn about, you know, global things, that we're able to use that to learn about our own past, is that the universe is kind of the same everywhere, based
Mm.
on our understanding. A very distant galaxy is in a different part of space, but space is kind of the same everywhere. The structure of galaxies is kind of the same everywhere. The way that structure is laid out, the way galaxies and clusters exist in the universe is kind of the same everywhere. So we are taking just a slice, but we're taking a slice through a fairly uniform kind of volume. So when we see what's happening, billions of light years away at very early times, we can imagine, okay, that's about what was happening here at very early times. And so we can
Right.
extrapolate and say we're learning about our own past, we're learning about, very universal things by seeing the past only as it was, in a distant part of the universe.
Right. It's so interesting that we have to accommodate, or maybe I should say account for the observer bias in all
Mm,
of the observations and all of the calculations that like we only know what we know through that lens.
mhm,
It's interesting that even in something that we often think of as the most sort of concrete, the most sort of logical, positivistic field, which
mhm,
is, physics. Like we think of that as
mhm.
the bedrock. Like these are
Yeah,
observations, they are what they are. There are laws. We actually use the word
yeah,
laws.
yeah.
Yet even there is almost this. it's not a constructivist view in the philosophical or psychological sense, but there's almost this bias that's built in that is what it's the Schrodinger's cat thing. It's like we only know what we know based on what we can observe given our tools and based on where our stance in observation.
Yeah, I mean, we have
It's
to.
fascinating.
Yeah, I mean, we have to take into account the possibility that, maybe our part of space is a little bit different on our, than the average, but we also have some sort of basic principles that we're not in a special place in the universe.
Right.
There's nothing really special about where we are, so we can make these inferences, and that seems to hold up. But we always do have to take into account the fact that exactly what we see is not going to be exactly the way it is everywhere else. And, there's sort of statistical averages and sometimes, we might draw conclusions based on our observations where we have to take into account, that there could just be some fluctuations, the fact that it would look a little bit different if we were 5 billion light years in a different part of the universe. We have to take into account those uncertainties and, that kind of just cosmic fluctuation. We call it cosmic variance, the fact that things might just be a little bit different somewhere else. And so we have to sort of just take into account that in a statistical way.
Right. And so, speaking of this sort of like statistical understanding or this
Mhm.
statistical attempt at understanding not just our place in the cosmos, I think sometimes when we say our place, what we really mean is a multidimensional place. So it's not
Mm,
just our physical place in the cosmos, but it's also our place in time.
yeah.
And of course, that brings us back to this idea that what we know about what could happen
Mhm.
at the end of it all is fundamentally based on what we've observed about what did happen,
Right.
right?
Yeah, yeah. And the big things that we observe, the biggest thing that we observe is the fact that the universe is expanding.
Okay.
And this is something that there are a lot of misconceptions about what it means for the universe to be expanding. A lot of people, when they envision the Big Bang and the expansion of the universe, they envision, okay, there was like an explosion in one point in space, and then that's been spreading out, and it's not like that.
Yeah, like a balloon is just stretching even bigger and bigger, but there's still an
Yeah,
edge. There's still an outside.
yeah, it's not that there was an explosion within space that then spreads out through space. It's that based on our understanding, there was a time very early on when the universe was hotter and denser and in some sense smaller than it is now. And that's really the Big Bang theory. And that's
Mhm.
the most basic statement of it, that the universe was hotter and denser in the past, that it was in some sense smaller and it's been expanding since then. And we don't know if there's any kind of edge. We don't believe there's any kind of center. We think that every place in the universe was hotter and denser in the past. The universe might be infinite in extent. It might be infinitely large. And just a long time ago, every part of the universe was sort of just denser. All that space was more compressed, but it was still infinite. That's a
Yeah,
possibility.
that's
That's something
so
that we
hard to fathom that
it's very
it
hard to
wasn't
fathom.
in compressing it didn't actually make it smaller. It just
Yeah,
made it more dense
like the
all
distances
everywhere.
between things were smaller, but
Right,
that doesn't
right.
mean, and you can imagine one way to imagine it is imagine that there's this sort of like grid, and that grid's being stretched out, but it doesn't have any edges, so
Yeah,
the
that's the
spaces
hard part to
between,
imagine.
yeah, but like the spaces between things is that's getting bigger.
Right.
One way people often envision it is imagine that you have a balloon and you draw little galaxies on the outside of the balloon, and then you blow up the balloon, and each galaxy is getting farther away from every other galaxy, but there's no edge to that space, like
Right.
in the two-dimensional space in which the galaxies live. There's no edge to that, there's no center to that, they're all just getting farther apart from each other. I don't know if that's really a helpful analogy or not, because then you imagine like, oh, we're embedded in a larger space. Well, maybe not.
Yeah,
There's
that's
a
the
lot of
part
this.
that the only way that my mind doesn't my brain doesn't ooze out of my ears when I try to
Mm,
think about this is that I think about, my experience in the biology lab. And let's say I'm looking at cells under a microscope. And at any given
mm,
time, I'm looking at such a tiny little field of
yeah,
view that if
yeah,
I can see an edge to my field of view, but then if I
right,
just move the slide, there's just
right,
more and more
yeah,
and more, no matter how much I move the
exactly.
slide.
Exactly, yeah, and so what we observe about the universe is that we see distant galaxies in our universe, and we see that they're moving away from us, and we see that they're moving away from each other.
Hmm.
If we were in a different galaxy, if we were in one of these distant galaxies ourselves, we would also see that the galaxies are moving away from us and moving away from each other, and that's a consequence of all of the spaces getting bigger, all of the spaces between things, all of that space is getting bigger, and it doesn't mean that
Right.
galaxies themselves are getting bigger, like, we're not getting larger, but the empty spaces between objects in the universe, that's getting larger. Okay, so
And
it
is that because
started
our own gravity is strong enough to prevent us from kind of breaking apart?
basically like if there was if a galaxy is already formed, then it's
Mhm.
already overcome the expansion, like all of that stuff
Okay.
has already come together by gravity and the expansion of the universe, as far as we know, and I'll get into this in a minute that where
Yeah.
it could be different, but based on our current understanding of what's making the universe expand, we don't think that that can break apart things that are already sort of gravitationally bound, right?
Okay. All
So
right.
so it looks like the universe just gets larger in its empty spaces. Um, there's some sort of stretchiness in the universe, but it doesn't break apart objects. So,
Okay. All right. For the
so what?
most part. Like I
Yeah.
envision almost like a black hole that no matter how much you pull on the outside of the event horizon, it doesn't matter because whatever's on the inside is bound. You're not going to pull things out of the black hole from outside of it, kind of like the same because I always imagine a black hole as like a very
Mm,
extreme example of gravity.
yeah.
I don't know if
Yeah.
that's a good way to look at it or not, but like an
Yeah.
extremely collapsed kind of unit.
Mhm.
Whereas our own universe, or not our own universe, our own galaxy or our own solar system or even our own planet, it doesn't necessarily have an event horizon, or does
Mhm.
it? Where like
No. No.
there's that force beyond which things will be pulled apart, but within it, the force is strong enough that it won't kind of like strip us of ourselves.
Sort of, yeah. I mean, the way that we think that the expansion of the universe works is, well,
Hmm.
so we think that somehow it was set off by the Big Bang. So that part
Okay.
is real fuzzy, and we don't really know. We don't really understand the very, very, very beginning. But we think that something happened, set off the expansion of the universe. So the universe went from being this very hot, dense state to the universe expanded. That fire, that plasma cooled. The things got less dense. For a long time, there was just a lot of darkness, and then gravity started to pull together gas, and you made stars and galaxies and so on. And the universe has been expanding, and for a long time there was this question of, will the universe expand forever, or
Mm.
will the gravity of everything in the universe slow down the expansion of the universe and pull
Oh,
everything back?
right.
And so
Okay.
this was the debate, up until the sort of 60s, 70s, 80s, a big debate about whether the which one of these things would win. There's this expansion kicked off by the Big Bang, and then there's gravity kind of putting on the brakes.
And then the
Just
question is, would it become a big crunch?
Yeah, yeah. Would the gravity win, which would
Mhm.
cause a big crunch, or would the expansion, the initial sort of kick of the Big Bang, was that enough that it'll just keep expanding forever? And the
Mm.
analogy I often use for this is throwing a ball up into the air. So if you throw a ball into the air, there are sort of three things technically that could happen, right? So the first one is the one you expect, right? Like, you throw the ball up into the air, you've given it a kick. Imagine that little kick is like the Big Bang. You've given it a push into the air, and then from then on, it's just gravity, right? Like, the ball is moving upward, but it's being slowed down by the gravitational pull of the Earth, and it
Mhm.
stops and it falls back down. So, right, so it's the gravitational attraction between the ball and the Earth slow down the trajectory of the ball. It stops, it comes back down to Earth. You could imagine, if you were really, really strong and you could throw that ball up at 11.2 kilometers per second,
Uh,
then you could reach escape velocity. right? So if you just gave it enough of a push and you didn't have to worry about drag or whatever, then you could, in principle, kick it up fast enough that it would just escape the Earth's gravity, which means that it would be sort of slowing all the time, but it would eventually be sort of not. It would not fall back down, right? It would just barely.
That's kind of like our
down.
event horizon is our escape velocity.
Well, I mean, event horizon is a slightly different idea, but this is a possibility where maybe the universe would never recollapse, right? If the initial kick of the Big Bang was enough enough of an expansion that it could overcome that gravity, then you could have a universe that expands forever, but it's always slowing down, right? Because the pull is always there. Just like if you threw a ball up in the air, if you threw it just at the escape velocity, it would slow down, and at sort of infinity it would stop, right? But it would be always slowing down. You could also throw it much, much faster than the escape velocity, where it would slow down a little bit, but it would sort of reach a sort of constant speed, where if you threw it so fast that the gravitational pull between the Earth and the ball was basically unimportant, then it would sort of get to a sort of constant speed and just coast off into the universe forever. And those are the three possibilities that we thought we had for the universe. We thought that either there was so much gravity that was going to overcome this initial kick of the Big Bang, or the Big Bang was enough that the expansion would just continue forever. And
so which one was dominant up until you said like the 70s, 80s, 90s? What did we kind of hang our hats on in the physics community?
For a long time, we thought it was the Big Crunch, until like in the 60s, people were writing papers about the Big Crunch, where, we really thought there was going to be enough gravity that it would slow down and stop the expansion of the universe, and everything would come crashing back again. And
then maybe just keep going. There'd be another Big Bang and then another Big Crunch.
Not necessarily. Like that kind of cycling may or may not happen with a Big Crunch. It's actually not that easy to formulate a theory where it bounces back. It's fairly easy to formulate a theory where it just collapses and
then that's it.
And that's it. Yeah. Okay. So for a long time, what we thought would happen is that the expansion would stop, everything would come back together, and you would get back into that state of sort of extreme high density hot universe, right? So everything would be incinerated and crushed. And that's the Big Crunch. And
that in essence is a scenario that would be the end of the universe.
Yeah, and that's the first one I go through in the book. And the fun thing about that idea, I mean, it is the least likely based on our current understanding in some sense, but the fun thing about it is to imagine like what that would actually look like. What like if you could imagine reading in the paper, oh, by the way, the universe is going to collapse and here's the date where it's going to happen. Like that would be a really troubling idea. And the thing that would destroy everything in that scenario is not really just things crashing into each other, but the thing
because that's the first place my mind goes is like the moon is just going to like slam back into the Earth.
Well,
like,
I mean, you would get galaxies crashing into other galaxies, which when that happens, and we do see that happen out in the universe, galaxies do collide sometimes. And when that happens, usually what happens is that a whole lot of the gas within these galaxies collides and you get more stars forming when that hydrogen slams together. But the stars themselves don't hit each other because there's still a lot of empty space in a galaxy. So even a head-on collision between galaxies, stars don't tend to actually collide. So we could collide with another galaxy and not really disturb the solar system. And in fact, we are going to collide with another galaxy because the Andromeda galaxy, our nearest neighbor large galaxy, is actually already coming toward us. We are already gravitationally bound to the Andromeda galaxy. It's coming at us at 110 kilometers a second. It's going to get here in about 4 billion years. So
wow. And we may never crash into it, but just coalesce with it and have like new neighbors.
Yeah, I mean, basically the orbits of stars will get all mixed up. The gas will crash together. There'll be some new stars forming, but the idea that something will actually hit our solar system is fairly unlikely, right?
Oh, cool.
So it'll be an interesting thing to see if anybody's still around to watch it. But that, it's in itself, that's not a cataclysmic event. The thing that kills you in a Big Crunch scenario is the fact that it's not just all of the galaxies and all of the sort of matter in the universe that gets compressed. If the universe is collapsing, then also all the radiation in the universe gets compressed. And I mentioned before that that when the universe is expanding, it kind of stretches out light and shifts it to lower frequencies. So you get yellow light turns to red or whatever, and visible light turns to radio waves, and you get this sort of lower frequency, lower energy light.
So it's
If the
literally
universe,
moving up the electromagnetic spectrum, just like
yeah,
shifting a little bit. Okay.
yeah, exactly. And if the universe is collapsing, then you're shifting to higher frequency light. So visible light becomes UV and becomes X-ray and becomes gamma ray.
Oh,
And
that's
so,
not good.
no. so so you're compressing all of the light from all of the stars that have ever shown in the universe, all of the high energy processes that produce X-rays and gamma rays and all of that is compressing, and it's becoming harder radiation, it's becoming stronger, and there's more of it. And so what happens is that stars catch fire, right? So what actually happens in this scenario is that the surfaces of stars get so cooked by the ambient radiation of the universe that you start getting thermonuclear explosions along the surfaces of stars, and that destroys them. And so in the Big Crunch, everything is incinerated by this sudden conflagration of stars. I think that's amazing.
Oh my God, that's
Yeah.
insanity.
Yeah, yeah. So
But of course, you mentioned that's probably not going to happen.
probably not gonna happen, yeah. So
Okay.
so,
All right. All right.
rest
Check
assured,
that one off the list.
yeah, yeah, but it's fun to calculate anyway, but yeah, probably not gonna happen. So
So what do you think? How should we go about this? Do we want to dive into the other four potential scenarios? Do we want to do a quick list and maybe focus on which
yeah,
one probably is there one that probably will happen, or is it like there's a
yeah.
few we're sort of
So
dancing between?
the one that will probably happen, so I can go through these a
Mhm.
little bit quickly. The one that will probably happen is called the heat death, and that's the one that we think is most likely based on what we see in terms of the expansion of the universe now. And
Okay.
so basically what happened was after we figured out that probably we're not going to get a big crunch, after we figured out that probably the universe is going to keep expanding forever, in the sort of 80s and 90s, there was an effort to figure out like how quickly is the universe slowing down in its expansion, because we knew that gravity was putting on the brakes of the expansion, and we figured we just want to know, like, how is this all balancing out, right?
Yeah, what's that rate? Is it
Yeah,
getting
yeah,
so the idea is that it's the universe is expanding, but it's expanding slower and slower and slower over
that
time?
that was the idea. That was what everybody
Okay.
expected to find, because we knew that it was kicked off by this big bang, and it's been, the only thing that's been acting on it since then is just gravity, right? It should
Yeah.
just be slowing it down. And so astronomers went out to try to measure the deceleration parameter, right? How quickly is the acceleration slowing down, right? Or
Mhm.
expansion slowing down. And so they went and measured it, and they found something shocking, which is that the deceleration parameter was negative. Okay,
No,
so
that's an acceleration parameter.
exactly. So the universe was not slowing down at all. It was actually speeding up. And this is very, very weird, because it's kind of like if you throw a ball in the air and it slows down for a little while and then just shoots off into space for no reason, right?
Oh, so it's
That's
almost like it's not even any of those 3 scenarios because it
exactly.
shoots off in space and then goes faster.
Yes, yeah, and that's what we saw the universe doing, and
Yeah.
that was shocking. That was such a bizarre result. Like, why would that happen? What is it
And
that's
where
making
does
the
that
universe
energy
expand
come
faster?
from?
Right, right. And so there was, it caused a lot of, discussion in the community. And what we settled on is that it looks like it might be something called a cosmological constant, which is an idea that Einstein originally came up with. An idea where there's a kind of stretchiness just built into how space works. And if
Mhm.
you have a bit of space and you leave it alone, then it'll just kind of stretch out over time. It's a parameter in the model of gravity. Just there's this sort of internal energy of space that stretches it out, and it's called the
Okay.
cosmological constant. And it fits with this with our observations, which is that we observe that the universe was slowing down for a long time, for the first few billion years, and then around 5 billion years or so ago, it started speeding up. And the reason for that is, in the early universe, when it was very much smaller and denser, the gravity was the important thing. So the gravity was really slowing down that expansion. But then as you had more and more space because the expansion had been happening, then that sort of pushing part started to be the dominant force. So there was
Okay.
more space, so there was more of this internal pushing, more of this cosmological constant. And so then that started to take over. And then the gravity by that time wasn't strong enough because everything had already been spread out so much that the gravity between things was not enough to slow down the universe. And so then it just started speeding up and speeding up and speeding up.
Almost there was like a spatial threshold in a
Yeah.
way. Like
Yeah.
I'm thinking again of my biology frame, and I'm thinking about neurons and how they often work, that you might have
Mhm.
chatter in your neurons. You might have one fire and one nearby might fire, but
Mhm.
when a sufficient number of them start to fire in a
Mhm.
synchronized way, then it just takes off. And you
Yeah.
eventually even get this kindling effect, which is a seizure, where
Mm.
like where they recruit all the ones nearby and it's this
Right.
runaway effect. So it's
Yeah.
almost like you have to reach this threshold and then it's like, we're off.
Yeah,
We're off
yeah,
to the
or like
races.
yeah, or like, like if you're sort of stretching rubber bands between your hands or something and it's getting harder and harder to stretch them, but then once they're far enough apart, then they break and then you just,
Yeah. And then
it's
you just put out your eye.
yeah. Yeah, right. Yeah, and so the universe kind of went through this process as far as we can tell. And so that if we follow that into the future, what it leads to is the idea that the universe is going to keep expanding forever. It's going to keep accelerating in its expansion. And eventually the universe will be a very cold, dark, empty place because
Aw.
everything is getting farther apart, things are interacting less, there's just less happening. And
Mhm.
we can already see that this process is occurring because we can look back in time by looking at very distant things and we can see that in the past there were more interactions between galaxies. Galaxies were colliding more often, more stars were forming more often, and so all of that slowed down. There's fewer collisions between galaxies, fewer stars are forming, and that's going to happen less. There's going to be less and less of that as the universe gets bigger and things get farther and farther apart and interact even less. And so, one of the things that I found out in the sort of process of researching this book is that we can calculate the rate of star formation in the universe, and we can find that if we look at all of the star formation that ever happened in the universe, based on gas coming together and forming new stars, we can calculate that of all the star formation that ever was or that ever will be in the future, about 90 or 95% has already happened.
Oh, shit. So we're sort of on the tail end of this process.
Yeah, yeah, from now
Wow.
until the end of time. Like, the
Wow.
universe is just making, 5 or 10% more stars. Isn't that
Oh,
wild?
wow. That's bananas, and
Yeah.
I mean, it also so we talk about this as the heat death of the universe, and I'm sure that makes sense from a physics perspective, but from a
Mhm.
layperson perspective, it almost sounds like it's the cold death of the universe,
Yeah.
like the lack of
Yeah.
heat death of the universe.
Yeah, it's sometimes called the big freeze.
Okay.
The reason we call it the heat death is it's actually we're using heat in a technical sense there. So
Mhm.
in physics, heat is disordered energy.
Okay.
And so as the universe evolves over time, more and more of the energy in the universe becomes heat, becomes disordered energy. As a star shines, for instance, it's converting hydrogen into helium in its core, and it's letting out radiation, and it's just heat. You
Yeah,
know,
just like fire, like
yeah,
when
like
there's that
fire.
combustion, it gives off
Yeah,
energy in the form of heat.
yeah, and also any process that happens in physics, anything that happens in the universe, there will be some disordered energy that comes out of that, some entropy. So, for
Mhm.
example, the reason you can't have a perpetual motion machine is because there'll always be some friction and you'll lose some energy to heat, to like
Mhm.
waste heat, right?
And eventually you'll
And
just run out of energy.
yeah, yeah, it's just kind of things decay and wear away and you get more entropy. And that's the second law of thermodynamics, this idea that as the universe evolves, the entropy increases. As
Mhm.
any process carries on, there's more and more entropy, more and more disordered energy, waste heat. And so the universe, as it evolves over time in this sort of eternal expansion scenario, more of the energy of the universe turns into waste heat. Stars will form and burn out and die, and particles will decay, and eventually all that's left in the universe will be just this waste heat of creation. And that's called the
Right.
heat death.
So what happens after like stars themselves burn out and die? Do they become these carcasses, or do they literally just dissipate back into the sort of particles that they were originally made from?
Well, it depends on the type of star. So some stars
Mhm.
will die by exploding as supernovae. Some stars will collapse into black holes or leave neutron stars after the supernova process. Some stars just become a sort of dead star at the end. Our star, when it burns out, will leave a white dwarf, which is a kind of compact remnant of a star.
Okay.
And then those things will cool over billions and billions of years and just slowly sort of fade away and decay. So
They
it
do
it
decay, though. Everything
yeah,
does ultimately just
it
become
does.
uncontained.
Yeah, yeah, everything
Okay.
decays and falls apart, and that's just the law of physics as far as we can
And then
tell.
you end up with just these particles that have space between them
Yeah.
that
Yeah.
are uncoalesced.
Yeah, yep, and
Weird.
just more and more spread out, and then
And
eventually the
uniform
universe.
eventually, yeah?
Sorry? Yeah, sorry?
Uniform? Like, just
Basically, yeah.
homogeneous eventually?
Yeah,
What?
yeah, eventually you have a universe that's just, like, sort of empty space with a tiny amount of trace radiation hanging around, and that's it. And then you've reached this maximum entropy state where everything is totally only waste heat, right? And the weird thing about that maximum entropy state is that because of this idea of the second law of thermodynamics that entropy only increases into the future. If you're at the maximum entropy, if entropy cannot increase anymore, there can't be a future, right?
Right, yeah, ooh, I
So
love that.
so you can't have a future in time. The arrow of time kind of no longer exists, and time doesn't mean anything anymore. It still
Yeah,
it still exists in a sense, but no progress can occur. Nothing can be built, nothing can form without just immediately decaying again. And you could have these weird little random fluctuations of stuff. And I talk about this in the book a bit, where you can have sort of something can fluctuate out of the sort of vacuum, and
mhm.
and appear, but then it'll disappear again, and that leads to a lot of weird things that maybe we can talk about later if you want. Um, but it gets a little bit strange and complicated. But basically, nothing can happen anymore.
And in a way, that's sort of like I find comfort in,
Hmm.
this vision of the end, which I
Mm.
don't know, might be, sort of existentially terrifying to
Mhm.
a lot of people, but I think it speaks also to my own personal, lack of a religious stance. It speaks to my own personal philosophies, but this is almost like the ashes to ashes and dust to dust
Yeah.
worm food end of the universe, except there are
Yeah.
no worms anymore either.
Yeah. Yeah, but it's definitely, I mean, it's a very slow process. It's just a
Mhm.
sort of gradual decay. I do find that a lot of people find it to be a depressing notion that
Mm.
we end up more and more isolated and colder and darker, and and just everything kind of falls apart. Um, some people prefer the idea of a big sudden boom, something
Right.
that would be more dramatic.
But I
But
wonder if that's really kind of assuaging in a way the death anxiety that most of
mm,
us carry in our minds. That's something, like you said, dramatic,
mm,
celebratory. A lot of times when you ask people who are very afraid of death, how do you want to die? They'll
yeah,
say, I want to die suddenly. And
right.
when you ask people who have a higher sense of, mortality salience is the term that we use in
Mhm,
existential psychology, how they want to die, they might say, I want time so
right,
that I can finish my business, say goodbye to the people, close out my relationships, do the things I wanted to do.
right.
I like the idea that if I know I have a terminal illness, that gives me the amount of time for closure. And so it's
Yeah,
interesting that parallel between how we ourselves want to die and how we want to see the universe that contains us to ultimately
Right.
end.
Yeah, yeah. I mean, when I talked to other cosmologists for the epilogue of this book, where I basically went around all my colleagues and I asked questions that were relevant to the physics of the book, but I also asked questions. I also asked everybody, how does the end of the universe make you feel?
Mm,
Because I thought, this is an interesting question to me,
yeah.
and a few people thought that the heat death was just such a depressing topic. They thought, that can't be how our universe ends. Like there has to be something else. And I thought that was really fascinating that some people just really didn't want to accept the idea that we could just fade away and that would be it.
Oh my gosh, I'm like obsessing over this. So you have so when you interviewed all these different cosmologists to kind
Mhm.
of pick their brains and get their insights, you also ask them this fundamental question. I'd
Yeah,
be so fascinated to follow up with that
yeah,
and go back and ask them how they themselves want to die and see
right.
what parallels exist there.
Yeah, yeah, that
Oh my
would be really
gosh.
interesting.
It's just it's amazing how much the concept of the beginning and the end of everything is
Mhm.
so tied to the concept and the beginning and the end of ourselves, because for so many of us, for all intents and purposes, we are where the universe begins and ends. And the
Mhm.
concept of something larger than us is not just disorienting and awe-inspiring, but also oftentimes moot in the
Mhm.
grand scheme
Yeah.
of things. It reminds me, I have a tattoo on my ribs of a quote from Carl Sagan,
Mhm.
when he said, "We are a way for the cosmos to know itself." And
Yeah.
I'm interested in all of this kind of, deep physics meets philosophy that you've been
Yeah.
doing throughout the development of your book. How do you make sense of that statement?
It's, it's an interesting thing. I've spent, I spent a couple of years really, really deep into the destruction of the cosmos.
Mhm.
And I am not somebody who has, what did you call it? Death salience? Like,
Yeah, mortality
mortality
salience, yeah.
salience. Yeah, I'm not cool with it. I'm not cool with the
Right,
idea of my own personal death. I don't like it. I don't wanna think about it. I don't I don't want
right.
I don't want anybody I care about to die. I don't wanna die. Like, I find that very troubling.
And
And
how
so
could you not while you're doing this research?
yeah, and so thinking about the end of the universe and accepting that the universe is gonna die and that, no matter what happens, everything will be destroyed.
Mm,
That was I found that very confronting.
mm,
And especially this idea that we're not gonna have a legacy at some point, right? Like so when we think about our own personal death. Like sometimes, I mean, you'll know more about this than I do, but sometimes people think about their own death and they're like, well, it's okay because I will leave behind something. I'll leave behind family. I'll leave behind, some work that I've done, some insight, some effect on other people. Maybe I was
right.
kind or whatever. Like there's something that you'll maybe you can leave the world a better place or just have some kind of impact, even in the sense of the most basic kind of impact of every action changes the universe somehow. Everything that you
Right.
do has some impact on the world, even if it's just a tiny, butterfly effect kind of thing. Like
Mhm.
somehow you leave a mark, right?
Yeah,
And so sometimes we come to terms with the idea of death by thinking about that.
and it's
And
actually, so that you know, to interject, it's
sure,
actually one of the interventions that we use
mm,
when we're working with people who are dying. One of
right,
the things that we do are life review interventions, interventions that require making videos or making
mm,
journals or,
right,
physically producing artifacts to leave
right.
behind for our, family, friends, whatever. And some people like to, take ownership and take control of how they want their funeral to be or what they want
Right.
to happen with their remains in their honor. And that's legacy building. That's a
Right.
big source of comfort for us, yes, as we do
Yeah.
take those final breaths.
Yeah, yeah, and the thing I think that is so upsetting or confronting about the idea the universe is going to die is that it's very clear that at some point that legacy will not exist. Right.
Yeah.
There will be a time when all of those memories are gone, when everyone who could have remembered you is gone, when every effect that you could have had on the universe is erased and the universe is just entropy, right? And so it's very hard if you're somebody who thinks about who accepts the idea of death by by thinking about your legacy. It's hard to figure out how to conceptualize it then if that legacy will be erased, and it'll be billions of years in the future or whatever, but it's still at some point it will not have
Mhm.
mattered that we existed, right? It will not have mattered
Right.
that our species existed. It will not have mattered that we learned about the universe. It will all be gone, and that is a really hard thing to come to terms with if you're somebody who envisions meaning in that way. And
Yeah, and it's
so
interesting that you even use that word "meaning" because
yeah,
that's what it's so fascinating, the core so long story short, because I don't wanna hijack
sure.
this with the existential psychology conceptions, but I subscribe to a view that's based in, a lot of fundamental existential philosophy, Kierkegaard, Heidegger, Sartre, a lot of these other Camus, a lot of these other individuals, which was then developed by psychologists who utilize
Mm,
those philosophies. And one of the psychological practitioners, but also deep theorists that I resonate with is a guy named Irvin Yalom. And he set forth this idea that there are five fundamental givens of existence. And what we all must grapple with in our human state is those givens. And they are fear of death,
mhm,
meaninglessness,
mm,
isolation,
mhm.
and actually, did I say 5? Because I'm thinking now it's 4, and the push and pull, between freedom and responsibility. So that
Right.
kind of, continuum.
Mhm.
Um, and those fundamental givens of existence are linked to each other. Like, even as
Right.
we're talking about a fear, maybe not of death, but of the, heat death of the universe,
Yeah.
it speaks to meaning.
Mhm. Yeah.
It goes
Yeah,
back to that
absolutely.
place.
And so when I was, putting together this book and talking to people about the end of the universe and all of that, it really struck me that if you want to really have meaning, if you wanna have meaning in this universe that's going to end, you need to find a way to construct meaning that doesn't rely on, some final reckoning, that doesn't
Mhm.
rely on how it's gonna be wrapped up in the end. It doesn't rely on some, eternal legacy that you have. You need to find some way to have meaning in the universe now that has no connection to the future, and
And
that's a
that is
hard thing.
it's a hard thing, but it's so fascinating, Katie, because it's one of our fundamental sort of, um, uh interventions
Mhm.
that this so there's two different ways that we often talk about existentialists often talk about meaning because it depends on whether you're like a religious thinker or a
Right,
non-religious thinker. So
right.
religious thinkers often believe that there is meaning imbued within in the universe, and it's our job to sort of expose it or
Mm,
excavate it or find it. And
right,
non-religious thinkers believe that meaning the absurdity of the universe is that there is no inherent meaning, and so it's
right,
our job to create it like artists,
right,
right? We make
right.
our own meaning. And I subscribe more to that. Different
Yeah.
people subscribe to different ones. But taking that frame,
Mhm.
the sort of takeaway that most existentialists get to, and the takeaway that I often work with my patients on, is the here and now, the
Mhm.
being in the moment,
Yeah.
the way that we commune with the cosmos, whether that be through other people or through deep introspection with ourselves, kind of
Mhm.
autonomously and independently, that we are alive right now, and this is the only moment that matters because we
Right.
can't guarantee the future.
Right. Right. Yeah, and I would take it farther. We can guarantee there is no future at some point.
Exactly, and to
And
find solace in those moments and to
yeah.
find equanimity is what we're talking about when we talk about God even, when we
Mm,
talk about these big I mean, I don't subscribe to that view, but that's what I think that fundamental nirvana, that
mm.
fundamental, whatever you wanna call it, is that being, that core being in the moment, and
Yeah.
it's a hard thing to do, and it's fleeting and
Yeah.
it's just out of our grasp sometimes, but we have those moments, right? We've all
Mhm.
had those moments where we feel so connected and so expansive that
Yeah.
we are one with the cosmos.
Yeah. Yeah, yeah, and I think that's so important, and I think that it also in my experience thinking about all this, um, it really made me think about life a little differently in the sense that
Mm,
it made me think about the importance of kind of appreciating and experiencing life as you have it and
yeah.
not being so focused on what you leave behind, or sort of the I don't know, the ultimate continuance of it. So while I was writing this book, my grandmother passed away, and I was fairly close with her, and so it was a big loss, and for various reasons, I wasn't able to. There wasn't like a big funeral or anything like that,
Okay.
so there was very little in terms of formal rituals around remembrance. I didn't end up with artifacts of her life or anything like that. And
Mhm.
so I really just had my memories of my time with her, and one thing that brought me some peace in that moment was thinking that, well, we all will die and there will not be artifacts of our lives at some point. Our belongings will be gone.
Mhm.
We won't be leaving things behind, and even the whole universe is going to die. And so what I had of her was the important thing, which is that I had the experience of having known her and having been with her, and the impact she had on my life, and the relationship we had. That's the important thing, and that I did have, even though I didn't have the artwork she kept on her walls or something like that. I did have the important thing that does have meaning because it's contained in the moment, and that
Yeah.
that brought me some peace. That made me feel a little bit of comfort in the moment of that loss.
It's that really beautiful and fascinating paradox. Like the heat death of the universe brings me comfort
Yeah,
because it's ultimate.
yeah.
And it speaks to, I think, one of the paradoxes that we often talk about in grief and bereavement work, which is that the reason we feel such a profound loss and the reason that we can grieve as heavily as we do and be as sad as we do is because that's an equal and opposite force to the amount of love we had.
Mm,
And, we wouldn't feel such loss if there wasn't such a great, experience
right,
to have lost.
right.
And so being able to tap into those memories and tap into those moments of that sort of pure beauty, love, God, community, whatever you want to call it,
Mhm.
um, they define in many ways how heavily we grieve and how strong our sense of loss is. There can't be one without the other. And to
Yeah.
me, a huge source of comfort when we're feeling like this feeling is literally the worst feeling and we're never going to get better, I'm never
Mhm.
going to get out of this, is that the reason that it's so dark is because the light was just so damn bright.
Yeah, yeah, and I think that I don't know, just kind of putting it in the context of we all will go through this, we all will lose things, we all will be gone, and the whole universe will be gone, and
Mhm.
if we're gonna find meaning in the universe, we have to find meaning in life as it's happening and in the connections we have to people, and there is sadness in the loss, but there has to be some we need to find ways to really also appreciate and value and treasure that joy that we have in the moments of existence, and I find that to be a kind of helpful framing of thinking about the universe and also about just my own existence and the existence of the people I care about.
Absolutely. It's again that very interesting idea that the more that we reflect on the end in a healthy way,
Mhm.
not in a sort of like a pathological or obsessive way, but the more that we think about these big questions and we reflect on the fact that there will at some point in time be nothing, the
Mm.
more valuable the something we have right now is.
Yeah. Yeah, it's a good reminder not to just sort of ignore it and, you know, um,
It,
and, imagine that it'll matter somehow in the future, like, we need to, you know, experience it now.
yeah. And I think that's such important advice for so many of us who are struggling through this
Mhm.
pandemic to find meaning, or many people throughout their lives who find themselves living for the future, saying,
Yeah,
or living for the past, either way, constantly mourning what could have been, or saying, well, as soon as I finish my degree,
right,
then I'll be able to X. As soon as I get that new promotion, then I'll be able to X. Like,
right.
you are alive right now.
Yeah. Yeah, yeah,
Now is
exactly.
the time. Yeah.
Yeah.
Gosh, I know that there's stuff we didn't get a chance to cover. We didn't
Yeah,
talk about the other 3 potential deaths of the universe. We didn't
yeah.
get a chance to talk about all of the cool, developments and insights that we are gaining in the world of physics that allow us to, like, the
Mhm.
technologies
Yeah,
that are now allowing us to have whole new types of physics that
yeah,
answer, unanswered questions. A lot of those sort of, really important insights are within your book. I don't know
yeah.
how a book this it's a really manageable length, guys. Like, this is not a tome, and
Yeah.
it's endlessly readable and super, like, funny,
Mm,
but somehow you managed to touch on so many of these important themes, and maybe it's good that we didn't get to them because it just means that there's, like, a little bit of a mystery in these
right.
pages that
Yeah.
folks can dig into. Um Katie, it's always such a joy to talk to you. I wanted to make sure that people know that there was an earlier episode that we did. I'm actually going to look up the episode number right now so that people can find it easily. It was like
Mhm.
within the first year of my
It was
doing
a
the
long time
podcast,
ago. Yeah,
super long time ago. It was
yeah.
actually, thinking about it, 2 houses ago for me. That's like, oh, it was like 2 lifetimes ago. Um, and in that episode, we talked about some of your basic sort of theoretical research that you
Mhm.
do on dark matter. And so if
Yep.
people want a refresher on that, they can go back to that episode because that's a
Yeah.
really deep dive.
Mhm.
Uh, but before we go, I've got 2 things I want to ask you. Number
Sure.
1, is there anything that you wish we would have touched on that we didn't so that we can talk about it? And then number 2, I want to close with my 2 big questions that I ask everybody. But before we do that,
Uh-huh.
anything that we didn't get to?
No, I mean, I think, there's a lot more to talk about in terms of the end of the universe. There
Right.
are some different scenarios that are sort of more violent or more sudden, especially vacuum decay, which is my personal favorite, that is based on a quantum fluctuation. It could happen at any moment. Probably won't. Don't worry about it. But read more about it in my book. So there's a lot of that in the book, and I would just say also, I do think that, I get a lot of people asking me about the book, like, is this something that you could understand if you're not a physicist, if you don't have any background in science? And I
Mhm.
really think it is. I've written it for people who are not scientists, who don't have a background in science. There are not, sort of equations and stuff like that. It's very approachable, and if you're somebody who's interested in the topic, you will not find it, difficult. I don't think so.
Yeah,
So
that's important.
it's really written for everybody, and I hope that people have a chance to read it and learn something about our cosmos and how it works. And I did put all of my favorite bits of cosmology in there, and there's lots of jokes and footnotes and things. So I know we talked about some really heavy, deep stuff, but the book is fairly light, I think.
Yeah, yeah, for a book about the end of everything.
Yes.
And of course, that is its title, The End of Everything, Astrophysically Speaking, by Katie Mack. And it's so funny, Katie, I just found our old episode.
Mm,
First of all, I changed all of them so that they're no longer numbered, but
okay.
this was episode number 5. You were
Oh,
my
wow.
5th guest.
Oh gosh.
Yeah. And it's titled Late Night Cosmology because you and I stayed up at I was having people over at my house and we went upstairs to record at
I
like
remember that,
midnight.
yeah. Yeah, yeah, I remember that.
Oh, it was so great. So everybody make sure you check that episode out
Yeah.
too so that you can build on some of these ideas. But in the meantime, Katie, I was
Mhm.
hoping you could share with us because I don't even know if I was doing my last 2 questions that early. Um, sort of your answers to these pretty big picture questions, but I know you've been
Okay.
thinking about that. So, So the first one is, when you think about the future, what is the thing
Yes.
that fundamentally does keep you up at night? The thing that worries you, concerns you, that you have a sort of negative reaction
Mm,
to, maybe that you're a bit cynical or pessimistic about. But then on the flip side, what is the thing that you are genuinely optimistically hopeful for? And of course, this can be in any context. So I know we
right.
touched on some of those with regards to the ultimate end of everything, but
Yes.
you can change the timeline if you want to there.
Okay. Um, I mean, the thing that worries me and keeps me up at night is climate change. I think that that's I'm sure a lot of people answer this when they talk to you, but I I find I'm very concerned about how things are going to change in the future, and I don't see enough action by governments and people who are able to make a big difference on that, and so I'm worried about how bad things will get
Mhm.
as the climate heats up, as we have more fossil fuel burning and CO2 in the atmosphere. So I do worry about how that's gonna be and how many people are suffer and how it's gonna be, the people who are sort of least advantaged now who are gonna suffer the most, and
Right.
that's upsetting to think about. But
Yeah.
the thing that I'm hopeful about, I guess, or the thing that I'm looking forward to about the future, um, I think, we are constantly discovering amazing things about the universe. We are constantly learning more about the cosmos, about how the universe works. And I'm excited for what we will find out and, what we will discover and how we will improve our lives through new discoveries, how we will just have the joy of understanding in the future.
Mhm.
And I'm excited to see what we learn.
Yeah. And that's I love how that's also reflected in your book, when in many ways when you talk about it, maybe in a more narrow sense, but in some ways
Mhm.
in an even larger sense, the new
Yeah.
advancements that allow us to see our physical universe in
Yeah.
ways that we couldn't before, to peer
Yeah.
into the cosmos in a fundamentally new way.
Yeah.
Thrilling.
It is really thrilling. It's really exciting, and I'm so happy to be living in a time when we're learning so much and, when we know so much about the universe, and I yeah, and I'm very excited to see where that goes.
Well, Katie, this has been an absolute joy, as I knew it would be. And what a way to kick off 2021 here
Yes.
on Talk Nerdy. Thank you so much for joining me. And everybody, pick up her book. I know you're going to love it. It's on like all these top 10 lists for 2020. It's doing so well. It's a bestseller, and everybody's freaking out over it for good reason. It's called The End of Everything: Astrophysically Speaking by Dr. Katie Mack. Katie, thank you so much.
Thanks so much for having me. This was really a pleasure, and I loved hearing your perspective on existential, all these existential ideas and death and so on. This was really fun.
Oh, great. And everybody listening, thank you for coming back week after week and putting up with me talking about death all the time. I'm really looking forward to the next time we all get together to talk nerdy.